Hello students, the question says a compound microscope consists of an objective lens of focal length 2 centimeters and an eyepiece of focal length 6.25 centimeters separated by a distance of 15 centimeters. How far from the objective should an object be placed in order to obtain the final image at the least distance of distinct vision and at infinity? What are the magnifying power of the microscope? See, whenever you need to solve any question based on microscope or telescope, NCERT question especially, you draw the diagram that is given. So he has given two lenses. Let us assume this is where I place my object. Generally, I prefer to place the objects on the left side. So I call this lens as objective lens. And this is eyepiece because here we have our eye. But even though from these two lenses, eventually the ray would go to the eye, we won't draw it. While solving, even in NCERT, if you look at the diagram, there should be technically a third lens and we should represent it as eye like human eye. This is just eyepiece. But we don't draw it. Even in NCERT also, you won't find this human eye diagram. We only draw optical instrument lens. So once you understood this, so I'll just write it here. This is eyepiece. And he has given the distance between these two objective and eyepiece is 15 centimeters. So this is given as 15 centimeter. And he is also given how far from the objective should an object be placed in order to obtain the final image in least distinct of distinct vision. So let us assume we have an object here. So once we have an object, for object, this is the first lens, right? For lens 1, for objective lens, we have object distance u1 and image distance v1. So again, I will repeat, for objective lens, we have object distance and followed up by, if we get any image, we get a image distance. Same thing is applicable for eyepiece also. So eyepiece also has object distance u2 and image distance v2. Once we understood that objective lens has this and eyepiece also have this, let us try to get any one of them from the question. In the question, it is clearly given the final image. Final image means final image would be created by the eyepiece. So it is given final image should be at least distant of distant. Final image at least distance of distinct vision. So it implies that the final image V2 that we get, if you assume that this is where our human eye is, so V2 would be in front of the human eye and at a distance of 25 centimeter from it, because that's what least distance of distinct vision means. Least distinct of distinct vision means the final image created by the eyepiece would be, don't get confused with eyepiece and human eye. Okay, both are different. Eyepiece means it's a convex lens present inside the optical instrument, and our eye would be looking through the eyepiece. That's why the name is called eyepiece. So when we say the final image is at the least distant of distinct vision, the final image created by the eyepiece would be 25 centimeter in front of the eye. I hope you understood that. So we can say indirectly the final image is least distinct of distant vision. It implies that V2, since it is in front of the eye, anything to the left side I take it as negative, anything to the right side I will take it as positive. So V2 would be minus 25 centimeter. We already know F2, that is F eyepiece. It is given as 6.25 centimeter. From this, we can find U2. So let us try to find U2. 1 by V2 minus 1 by U2 equals to 1 by f2. So 1 by minus 25 minus 1 by u2 equals to 1 by 6.25. So if I solve it further, 1 by u2 equals to minus 1 by 25 minus 1 by 6.25. We can write this as minus 1 by 25 minus 4 by 25. So we finally get u2 equals to minus 25 by 4. So minus 5 centimeter. We got u2 as minus 5 centimeter. What does it exactly mean? What's the meaning of u2 as minus 5 centimeter? If I try to represent in a diagram, we got that u2 would be minus 5 centimeters from the eyepiece. Minus 5 simply means, remember, always I will take whichever lens we are dealing, we will take the center of that lens as origin. So once we take it as origin, left side would be negative and right side would be positive. Based on that, if this is 0, 0, minus 5 simply means this one. So we indirectly got the value as this one as 5 centimeters after solving it. Once we know this is 5 centimeter, we can find what would be the value of this. So this would be, this is 15, this is 5. We can write this value would be 10 centimeter. So based on previous result, based on previous result, we get V2, because this 10 centimeters is nothing but the image created by the objective lens. V2 is plus 10 centimeter. You might wonder how can this become minus 1 and how can this become plus 10? When you, not V2, sorry, it would be V1. V1 would be plus 10. You might wonder how this is 5 centimeter minus 5 and how this is plus 10. When I express V1, I have to take the first lens because this is the first lens, right? This is the second lens. The first lens as the reference. If I take first lens as the reference, it is to the right side of the first lens. So that's why V1 is plus 10. We know V1 is plus 10. In the question, F1 is already given as 2 centimeter. Since it's a convex lens, plus 2 centimeter, we have to find this u1. So let us try to find the u1 value. So 1 by v1 minus 1 by u1 equals to 1 by f1. So 1 by v1 would be 10 minus 1 by u1 equals to 1 by 2. So 1 by u1 would be 1 by 10 minus 1 by 2. I can write this as 1 by 10 minus 5 by 10. So u1 would be minus 10 by, so which is nothing but minus 4 by 10. So minus 10 by 4 minus 2.5 centimeter. What does minus 2.5 centimeter mean? That means from our, I will again redraw that lens. So minus 2.4 simply means that from our original lens, it would be on the left side. Negative sign indicates it would be on the left side. And it would be on the left side by a distance of 2.5 centimeter. This is the meaning of minus 2.5 centimeter. That's what we need to find. So we can conclude by saying that final image, if final image, if V2 is equals to minus 25 centimeter, we get U1 as minus 2.5 centimeter. So, or we can say 2.5 centimeter from objective lens. I'm not writing any minus plus. So I hope you understood how we have solved the first part. Let us use the same logic to solve the second part. In the second part, he has given final image at infinity. If we say final image at infinity, it simply implies V2 is infinity. If V2 is infinity, we no need to solve this, uh, we will get u2 value as minus f. So we will get this value as minus f2, or else I'll just write the step 1 by v2 minus 1 by u2 equal to 1 by f2. So if this is infinity, minus 1 by u2 equals to 1 by f2. Anything by infinity is 0. So 0 minus 1 by u2 equal to 1 by f2. So from this, we will get u2 equal to minus f2. Once we get u2 as minus f2, again, same thing. What is f2 value given in the question as? It is minus 6.25 centimeter. So if I substitute in the main diagram, so this length, now we got it as 6.25. So this is where my u2 is present. And the location, and from here to here, let us try to find what would be the value of v1, because this distance is nothing but v1. So 15 minus 6.25 will give me 8.75. So this becomes my v1. So the new values are v1 would be plus 8.75 centimeter. We already know u1 value is what we need to find. F1 value given in the question as plus 2 centimeter. Let us substitute all those in the next page. So we get 1 by v1 minus 1 by u1 equals to 1 by f1. So 1 by 8.75 minus 1 by u1 equal to 1 by the focal length of the first lens is 2 centimeter. So if I rearrange the terms, 1 by u1 equals to 1 by 8.75 minus 1 by 2. So u1 would be 8.75 into 2 divided by 2 minus 8.75. So 8.75 into 2 divided by 6.75. You will get, if you do it in a calculator, you will get approximately minus 2.593 centimeter. So we can even further approximate it as minus 2.6 centimeter. Minus 2.6 centimeter simply means if this is this one, so this length we got it as 2.6 centimeters. This is where the object is. As you can see, if the final image is at infinity, so we finally conclude that if v2 is infinity, it is only possible if u1 is minus 2.6 centimeters, or we can write 2.6 centimeter from objective lens. So I hope you understood how I have solved. Remember, this entire problem is like a reverse engineering. You have to, there would be u1 v1, u2 v2. So using u1 v1 and u2 v2, every problem, like there would be u1 v1. These belongs to objective lens, u1 v1 f1. There would be u2 v2 f2. So these belongs to eyepiece. Then what is the term that connects both of them? The term that connects both of them is length of the microscope. So length of microscope connect these two terms, because using length of the microscope, we can actually find V1. So length of the microscope connects these two. So based on the question, either from these three, two would be given and you will find the remaining unknown. Use that unknown again. From these three, one would be given, you will find the remaining unknown. In this way, we'll solve the problem. Ultimately, our goal is to find u1, v1, f1, u2, v2, f2, and length of the microscope. All the quantities have to be found at the end of the problem. I hope you understood like how I have approached the problem. And in the last one, he has asked what's the magnifying power of microscope in each case. So if you want magnifying power of microscope in each case, we can use a direct formula. But I hope till this point you understood it. Let us go for magnifying power of microscope in each case. the magnifying power is simply, for the first microscope, it would be V1 by U1. So we'll just go for magnitude of this. So V1 by U1. For the second one, since we take angular magnification, 1 plus D by FE. This is for case A. So I will call magnifying power as P. So P is equals to V1 by U1. So in the first case, if I go for V1 by U1, you got V1 as 10, U1 as 2.5. Into 1 plus least distinct of distinct division is 25. All these are magnitudes only, divided by focal length is of the eyepiece is given as 6.25. So it would become 4 into 6.25, 4 times 4 into 5. So it would be 20. I'm taking magnitudes for all of them. Again, no need to substitute the sign convention or anything. So it would be 20. That means we can say it is maximum magnification is 20 times for given case. 20 times per given case. Let us look at case B. Okay, this is also called as least strain case. For least strain case, again P equal to V1 by U1. So V1 value, we got it as 8.75 divided by 2.6. So 8.75 divided by 2.6 into, the formula won't be 1 plus D by Fe, it will be just D by F. So D by Fe would become, D value we know 25, Fe value is 6.25. So again we'll have 8.75 divided by 2.6. 8.75 divided by 2.6 would give us 3.3636 into 4. So we'll get approximately 13.46 as the power in the second case. So this is the power in the first case. This is the power in the second case. The formula for the second case is power equals to modulus of V1 by U1 into just D by F. So this is how we are supposed to solve this problem. Hope you understood it. Thank you.